What is biocatalysis? Well, it's a different way of carrying out chemical reactions. It's an alternative to using solvents. It involves using enzymes and small living biological systems to speed up chemical reactions by creating a lower energy pathway. This is really effective as it involves fewer steps than traditional synthesis methods. Using this method to produce animal feed has both advantages and disadvantages. The advantages are that the synthesis is cleaner and usually quicker than the equivalent solvent-based method, as well as the catalyst being regenerative and it can be used again. The disadvantages are that it can often be expensive and the catalysts are extremely selective about which temperature range they operate in. The use of enzymes as supplement in animal feed started in the late 1980s and has since then considerably evolved, particularly in the pig and poultry feed markets, mainly in the form of phytase. Biocatalysts were first introduced in the animal feed industry in the late 1980s and first commercialized in 1991. They improve the digestion of dietary components, which enhances feed conversion and hence growth. In order to do this, they need to be safe and overcome the effects of anti-nutritional factors. Biocatalysts are most commonly used in chicken and pig feed in the form of enzymes, most favorably phytates. Phytates are the most favorable enzymes as they provide phosphate and other phytate-bound nutrients by the degradation of phytic acid, a potential anti-nutritional factor, and for their promising potential to reduce phosphate pollution. This is possible due to the nature and conditions which phytates best react in, since they have been fine-tuned to be compatible with the system of typical farm animals. Remember this as we will be coming back to it a bit later. Animal feed is food for farm animals used to speed up growth. It has a complex manufacturing process of sourcing ingredients, processing, testing, and quality control. There are more than 900 types of ingredients used to make feed. These include grain, corn, distiller's grain, scrounge, natural products, minerals, sorghum, vegetables, nutrients, and wheat, just to name a few. Feed factories overall utilize 4 essential cycles to deliver creature food, accepting crude fixings from providers, making a feed recipe dependent on numerous long periods of examination, combining fixings to make a total feed, and bundling and marking feed to be transported for businesses or retail purposes. There is thorough quality control testing. Tests incorporate concoction, physical, and an electronic assessment. Testing plans should be made by quality assertion, sustenance acquisition, and creation staff. Feed and trimmings are tested for clamminess, protein, fat quality, fat amount, unrefined fiber, mycotoxins, microorganisms, and other important factors. Afterwards, the trimmings are consolidated to make a feed complete. The mixing cycle is a basic development in choosing the after effect of one thing. Trimmings can either be dry, liquid, or soggy. Dry mass trimmings, for instance oat grains, are added to the blender first, then followed by other dry materials, for instance minerals and supplements, or smaller than normal trimmings. There is a novel method of producing feed, minor trimmings. This process is known as whole crop biorefinery, either sprinkled or added to the mixed trimmings. The main steps in this are processing, milling, fermentation, and separation. In the processing stage, grain is used. Then either dry or wet milling will occur. In dry milling, the grain is grinded into flour, and in wet milling, the grain is soaked, and then sulfur dioxide is added to loosen the hull, followed by grounding. After milling, fermentation takes place, and is followed by distillation, typically via multi-column distillation plants. Then the residue obtained from distillation can be separated into a solid and liquid phase. The liquid phase is then combined and dried to become cattle feed. Another possible alternative is using straw. Straw goes through a different process, the lignocellulosic feedstock biorefinery, in which lignocellulosic materials, for example wood, are refined into cellulose and processed into feed. The optimal operating pH for phytases is 5.5 at a temperature of 37 degrees Celsius, which matches the pH and temperature of inside a farm animal's digestive system. In order to stop any anti-nutritional effects from occurring, the phytase needs to be hydrolyzed as quickly as possible. This is easily possible and usually occurs in the upper part of the digestive tract due to acidic saliva. When hydrolyzed, the phytase catalyst breaks down into amino acids, phosphorus, and energy, which is then absorbed by the animal. This does not affect the animals in any negative way, as it merely adds natural products to their food. Likewise, this does not affect humans that later consume said animal, as there are no traces of the catalyst left over. Biocatalysts in the animal feed industry have come a long way since their first introduction in the early 1980s. It has since become more efficient than the old technique of manufacturing animal feed. We now see finely tuned enzymes that catalyze the production of the feed and also help spread nutrients and energy throughout the system of an animal. In today's times, phytates are the most common due to their ability to break down once certain conditions are met. This makes for healthier animals and no dangers to consumers of the catalyst-fed stock, as no traces are left behind.